looking like this is on page 11 of your unit handout. And today is the final day where we're dealing with arithmetic. Starting tomorrow, we're going to be dealing with not arithmetic sequences, not arithmetic series, but geometric series and sequences. So today what we're doing is just more work with algebraic series and radical series. So I shouldn't say more work. We're going to be looking today at problems in which the terms in the series are not numbers like 2, 3, 8, whatever. The terms instead are going to either be radicals, like root 5, or algebraic terms like 5x. So they're not necessarily going to be numbers that we can play with in our calculator. And then we're going to be continuing to solve other problems involving arithmetic sequences and series. Number one, I will admit, number one is just a math problem. It has very little to do with your knowledge of sequences and series. It's an algebra problem. Okay? So it says determine the value of the first term for the series described below. Well, we have this formula that says Sn is equal to n over 2 times in brackets 2t1 plus in another set of brackets n minus 1 times d. And I'm using this formula because the other formula, can you take that out of your mouth, please? I just find it distracting. Thank you. The other formula has t1 plus tn, where tn is the last term, and I don't know the last term. So this formula, to me, is a direct way to solve this problem. I simply want you to note, before we get to work on this, that this number is going to go here. Right? We're going to sub in that value. This number is going to go here. I guess that's not very helpful. I forgot to change colors. This number is going to go there. And the value of n, which will go here and here, will be 13. So the only thing I want you to note here is once we do all of that substitution, there will be one thing left in the equation that we don't know, which is t1. Therein lies the algebra. We're going to solve that resulting equation for t1. So I put in 4992 equals 13 over 2 multiplied by, in brackets, 2 times t1, which we do not know, plus 13 minus 1 times d, which is negative 6. And look how I wrote that negative 6 in its own set of brackets. The last thing you would want to do here is write this, because that's not what we're doing. We're not subtracting 6, we're multiplying. Well, we're not subtracting 6, we're multiplying by negative 6. So you need to put it in a set of brackets. Once again, I've said this maybe a dozen times, a part of me just wanted to write the number 12 here. I mean, putting in 13, 13 minus 1 is 12, but I always leave it that way. So how do you solve an equation? And now I'm getting into math mode. This is just from last time I taught the course, I guess. Now I'm into math mode. I'm talking about algebra. The first thing you want to do with any equation, if possible, is to simplify the equation. And the word simplify here means exactly what it means in English. 13 minus 1 is 12. We don't, if I say go get a dozen donuts, I don't say go get 13 minus 1 donuts. If I mean 12, I say 12, right? So the 13 minus 1 is 12. And I guess I could rewrite the whole thing and have 12 times negative 6, but why don't I multiply 12 by negative 6 right now? Okay. So what's going to be in brackets here will be 2t1 plus a negative, it will be minus 72. So I'm taking 13 minus 1 to give me 12. I'm multiplying 12 by negative 6, and unless I've totally lost my mind, I'm pretty sure that's negative 72. So we're subtracting 72. What else can we simplify? Well, I can simplify 13 over 2. Only because, and we had this kind of brief conversation at the end of yesterday's class, only because it's a nice decimal to work with. If it were 25 over 3, then we would look at it in a different way. But in this case, when we divide it, we get a nice decimal. So now, how is it I get at the T1? Well, T1 is being multiplied by 2, and then 2 times T1 we're subtracting 72 from, and then this whole thing, everybody, is being multiplied by 6.5 to give us the 4992. The point is, I can't start peeling that thing apart until I take that 13 over 2 out of the way. Okay? That 6.5 is like a bow on top of the present, and we want to unwrap it. Well, you have to take the bow off first to get to the box. Okay? We're doing the opposite of bedmass here, if you really want to be technical. So I divide both sides by 6.5, and I normally don't write this, but because there are multiple steps, I'm just writing it to show you what's happening. So that's what happens. My confidence level in figuring out what that is extremely low. So I get 768. And now I am in, honestly, I'm in the grade 7, 8 realm of mathematics. The way you solve this equation in grade 7 or 8 might be different. You might be taught different strategies. You might be taught to solve it using algebra tiles of some case, in which case, as a student, I would just want to put my head down and go to sleep and wish somebody would just explain to me how to solve this. I need to add 72 to both sides and then divide by 2, right? I mean, it's a two-step linear equation. So I add 72 to both sides and get 850, I think. Can you confirm that, please? $840? 840, thank you. I know I make mistakes like that, but I'll be honest with you. The reason why I do that mental math is to keep my brain sharp. Okay, honestly, if I find if I teach a whole semester and all I do is bang away on the calculator, my brain falls asleep in certain areas. Okay, so I divide both sides by 2, and I get T1 is equal to, I'm pretty sure I got this one, 420. Okay. So the first term is 420. We've answered the question. There's no big meaning behind this. This question was about using algebra and learning and reviewing algebraic skills. What we've talked about in this question are skills that you would use maybe later on in the course. You would use the same set of skills. With something called the cosine law in the trigonometry unit, where maybe you're trying to find the value of C or capital A or something, where you have to rearrange. So this, I'm teaching you math by using an illustration with sequences and series. All right, let's move on. Determine a general expression for the sum of n terms. Well, this should be a breeze because we just did this with the question that was asked about, right? I have Sn equals n over 2 times 2t1 plus n minus 1 times d. And these formulas, by the way, would be given to you for a formula sheet. I don't think I've given you a formula sheet yet, have I? Okay, I'll provide one with you to you in the next couple of days. So we know that the first term is 3. The second term is 9, which means the common difference is 6. All we have to do is put those parameters in there. And just like putting the parameters, I want to just pull over for a second. Just like if you were to put the parameters into this, that you would get a general formula to find any term value. When we put those parameters into this equation, we're going to get a general formula that will find any term sum. So this formula on the bottom right is used to find T1 and T2 and T3. The other formula is used to find S1 and S2 and S3. So let's go ahead. Let's get to work here and put these numbers in. S sub n is n over 2 times 2 times the first term, which is 3, plus n minus 1 times the common difference, which is 6. I don't really need brackets around the 6, but what the heck. So what I would ask everybody to do is take a minute, like a minute or so, and simplify what's in brackets here. And it may require 2 steps, it may require 1 step depending on your skills. But if you are going to simplify that using 1 step, be very careful, because the less work you do, the fewer steps you do, the more likely it is you will make a mistake. I think it simplifies to 6n. Because we have that 6, and when I multiply that 6 by the n minus 1, I get a negative 6. So if you do this in 2 steps, it's 6, that's the 2 times the 3, plus 6n, and then minus 6. So I am left with Sn equals n over 2 times 6n. And again, look how I wrote that. Look at where the 6n is written vertically. You might think that's a picky detail. Oh, Mr. Way, he likes to have things lined up. It's because students will be better at doing the algebra if they follow these steps and rules and patterns. I can write this over 1. So when I multiply across the top, I get 6n squared. And I have divided by n, so n squared over n. Sorry, I have divided by 2. I misspoke. 6 over 2 is 3. So I get 3 times n squared. Well, I don't know if you remember what it was in the question that was asked about. And you don't have to do it in your calculator. It's just that it's a nice, clean method. Go into y1 and put 3n squared. And sometimes I will, instead of putting x squared, I'll go xx. And this time, let's go to our table setup, and let's put it on automatic. We'll start at 1 and go up by 1. So this is going to generate a table where we got the first n as being 1, and then 2, and then 3, etc. And when I go to the table, remember, this is s. This is not t. What's s1? 3, because the sum of the first term is 3. What's s2? Well, it should be 3 plus 9, which is 12, which it is. What's S3? It should be 3 plus 9 plus 12, which is 27, which it is. Okay, so it works. Any questions with number 2? Number 3, we have an arithmetic series. And by the way, the answer to this question is going to be what it is, regardless of whether it's arithmetic or geometric or anything else. Okay? The sum S8 is 120, and S7 is 114. The question is this. What is the 8th term? And I'm going to give everybody a minute to answer that question. The fact that I'm just saying I'm going to give you a minute to answer it tells you that the answer doesn't lie in algebra. There's not a long, complicated process here. When you see it, you can't unsee it. And those of you that don't see it, you're going, how on earth can I answer this question? Okay, well, let's let everybody off the hook here. Sukhman, what is the answer?
6.
It's 6. The 8th term has to have a value of 6. How many of you see it now? Listen, if S7 is 114, that means when I add together, and I'll write this out for you to help you see it in a second. When I add the first 7 terms, I get 114. why is S8 more than S7? Because S8 includes those 7 terms, and it includes the 8th term. I don't think you need to do this. I think you need to see what's going on. I'm going to write T1 plus T2 plus T3 plus T4 plus T5 plus T6 plus T7 plus T8 equals 120. And below that, I'm going to write T1 plus T2 plus T3 plus T4 plus T5 plus T6 plus T7 equals 114. If I subtract these, T1 plus T2 plus T3 plus T4 plus T5 plus T6 plus T7 plus T8 minus T1 and minus T2 and all of that, all we're going to be left with is T8. Right? If I subtract, all I'm left with now is T8 is equal to 120 minus 114, which is 6. Number 4 is what I'm trying to do today is expose you to a variety of different situations where you have to use your skills and teach you those skills. Okay, again, this is not necessarily about sequences and series. Let's read what this says. The sum of the first 2 terms is 13, and the sum of the first 4 terms is 46. Now, there are a lot of ways you can approach this question. You could into this formula what were the numbers? 13. You could put 2 for n and 13 for Sn and get a formula with T1 and D, and then repeat the process with 4 and 46 and get a second equation. But it's difficult. So let's look at a different strategy. What is S2? Okay, S2 is T1 plus T2. Right? Correct? But T2 is T1 plus a common difference. And I'm not using a formula here, I'm just using common sense that says the second term is the first term plus the common difference. What does that mean? It means we have a formula that says 2T1 plus the common difference is 13. We've had this conversation already. I forget, I had asked somebody over here the other day, why can I not solve this for T1? The answer is because I don't know D. Why can I not solve this for D? The answer is I don't know T1. So that leads us to Math 10 where we need a second equation. Right? We need a second equation. Well, I'm going to use the second piece of information, which says, it doesn't matter where I do it. I'll go here, T1 plus T2 plus T3 plus T4 is equal to 46. And there's a lot of places we can go here. For example, I could, I'm not going to, I could replace T1 plus T2 with the number 13 because that's what we're told. Instead, what I'm going to do is this. The first term plus, here's the second term. That's the second term. Plus the third term. Third term is the first term plus 2 common differences. So what I'm doing is I'm building formulas that only have T1s and Ds in them. The fourth term is the first term plus 3 common differences. And this has to be 46. There's no, occasionally in high school math, you get a type of problem that there's no necessarily direct approach. You just have to attack it with a series of strategies. And this is one of them. So my second equation becomes, let's count the T1s. 1, 2, 3, 4 T1 plus how many common differences? 2, 3, 6 common differences is equal to 46. You with me? So now we have a system of equations and we can solve this. The first thing I'm going to note, and I hope you see it, is that everything in this equation is even, so I can divide all of those terms by 2 and get a simpler equation. If I divide this equation by 2, it becomes 2t1 plus 3d equals 23. Can everybody please, and thank you, check my arithmetic there. I'm dividing everything by 2. Below that, I'm going to write the other equation, which is 2t1 plus d equals 13. And all of a sudden, the sun is starting to come. The clouds are dissipating and the sun's coming out. Because now I can see an end in sight. If I subtract these equations, I won't have any t1s. I'll just get 2d equals 10, and now I know the common difference is 5. And now that I know the common difference, I can use that to find the first term. I just want to read the question. Determine the first 6 terms and the sum of the first 6 terms. So I'm going to put this into 2t1 plus d equals 13. So I'll have 2t1 plus 5 equals 13 and solve this for t1, which should be child's play. Right? Subtract 5 from both sides, divide by 2. t1 is 4. For the sake of shaving a little bit of time off of this lesson, you can use that to find the first however many terms in the sum. I'm not going to do that. Okay? Let's take a look at number 5. I want to, part of me wants to just say, oh, let's not do this one, but let's do it. You could have done this one yesterday. What this is saying is, that these numbers at the top are not sums. When I say the second and the fifth terms, I'm just saying those are the terms. I think we have done this kind of question where what we want to pull out of this is T1 and D. I think we've done this type of question, honestly, 8 times. The idea is if I take 8 and I add 3 common differences, I have to get 29. Why 3? Because I'm going from the second to the fifth term. Maybe it benefits you to write blank 8 blank blank 29 to help you visualize that. But to go from the second term, which is 8, to the fifth term, which is 29, requires you add 3 common differences. So, again, we're into an algebra thing here. Finding D is easy. Can you please calculate D for me? Have you got it? It's 7. Good. So the common difference is 7. How do we find the first term? Well, you don't always have to use a formula. The first term is 1. Look at the diagram. If the common difference is 7 and the second term is 8, the first term had better be 1. Again, everybody, this is one lesson that I didn't shorten. We have shorter classes this year. I know you guys are aware of that. I didn't shorten this lesson, but I realize now I should have. You can find S15 by using the SN formula. I'm not going to do so. You could put in 15 for N, 7 for D, 1 for T1. I'm not going to do that. So for next time I teach this, I'll just change this question to find the first term and the common difference, which means I'll probably pull the question from the lesson because it's an old question. Okay, find the sum of the first 12 terms. Okay, so I want to write this out, just spaced out a little bit more. Can somebody tell me what 5x means? What does it mean when I say 5x? Go ahead. 5 times something. That thing is x. What does 5 times something mean? It means that. That's what 5x is. I'm not talking algebra tiles. I'm saying 5x, and I will often say this, is 5x's. That's what it means. It's 5x's. So when we say 2 root 3, which is 2 times root 3, it means we have 2 root 3's. So you're not going to write this down. I'm just saying that this means you have these things floating around in your head. And then the next term has that floating around. That's when we say 5 root 3, we mean 5 root 3's. And this, by the way, is something you would have been taught last year in Math 10. So, I mean, I hope it's obvious here that the first term is 2 root 3, right? What is the common difference? Sukhman? Not 3. What do we add? What do we add to this to turn it into that? We add 3 root 3. So if I have 2 root 3 and I add 3 of them, 3 root 3's, I get 5 root 3. If I add 5 root 3 and I add 3 root 3 to it, I get 8 root 3. So the common difference is 3 root 3. And now we can answer the question by using the sum formula to find S12. So S12 will be 12 over 2 times 2 times the first term plus 12 minus 1 times the common difference. And don't be intimidated by all these roots. Take it slow and simplify. Okay, so I'm going to have more steps in here than I need or than you probably need. But 12 over 2 is 6. I am going to show this to you maybe 15 times throughout the semester. If I ask you to take 2 times 3 times 4, how do you do that? You take 2 times 3 to get 6, and then you multiply by 4 to get 24. You with me on that? Could I take 2 times 4 to get 8 and multiply 8 by 3? Yes. The point is, when I multiply 3 things, you pick 2 of them to multiply, and then you multiply by the third. So 2 times 2 root 3 is 4 root 3. It's 2 times root 3. And 2 times 2 is 4. I'm not going to rewrite the whole thing to reveal to you that 12 minus 1 is 11. 12 minus 1 is 11. And 11 times 3 root 3 is 11 times 3 times root 3. And 11 times 3 is 33. So let's just simplify a little bit more and we will be done. What I have in brackets there, everyone, here, is kind of no different than saying 4 plus 33, or saying 4x plus 33x, or saying 4 kittens plus 33 kittens. It's no different, right? You're adding the things together because they are similar terms. And now we can go 6 times 37 times root 3. I don't know what 6 times 37 is. I think I do, actually, but can you work it out? I want to say 222. Is that right? Okay, so this is S12. This is 222 root 3. And we want to leave it that way. We don't want to calculate it as a decimal because the square root of 3 is an irrational number. Okay. I don't think we're going to have the fire drill in this period, but I know we're having a fire drill today. If we do, we'll just do our best. Okay? We'll figure out what the schedule will be based on that. I want you to look at these terms. I'm going to underline them. The first term plus the second term plus the third term, so T1 is 3x plus 2. I want everybody to figure out, just by thinking on it, what the common difference is. In other words, what is it you add to 3x plus 2 to get 4x plus 3? 1x plus 1. X is going up by 1x, the number is going up by 1, so the common difference is x plus 1. So things are getting, well, more dash 1 here. Right? These aren't numbers that we could put into our calculator. We're asked to find, I believe, S12, right? So that's 12 over 2, 2 times the first term, plus n minus 1 times the common difference. I can't help myself. Rather than writing 12 minus 1, I have to write 11. Okay, if you want to write 12 minus 1, write 12 minus 1. And then you'll go, oh, wait, that's 11. Right? I mean, you know that. So we simplify this. This is not a difficult procedure. What we are doing, everybody, and you may get tired of me saying stuff like this, but I think it's important, is we are taking a problem that's a grade 11 academic math problem, and we have turned it into, for the most part, a grade 8 or grade 9 algebra problem. That's your strategy in high school math, to take the problem and turn it into something you could have done last year or the year before. This line that I wrote is the only thing that's math 20-1. Because it's a 20-1 formula. Now we can write 6. This is 6x plus 4. And this is 11x plus 11. So I'm just multiplying this stuff out. We clean up what's in brackets, we multiply it by 6. In fact, everybody, I'm going to leave it like that. We're going to have this discussion again and again, but it's better to have things factored. Rather than multiplying it through in this case, let's leave it factored. We have one question left, which shouldn't take too long, and then you'll have some time to practice many of these on your own. This is a good exam question. I like to put this on our unit exam. Remember those formulas for Sn we found? I think I still have one tucked away in my calculator. It was 3x squared or 3n squared. So somebody has done that here, and they've told you this is how you find Sn. What are the first 5 terms? Okay, well, let's use our calculator here to shave a couple of minutes off of our work. I'm going to put this formula, this expression, 2x squared plus 5x in my calculator. And I'm going to go, and please humor me, set up your table so it's ask. Okay. And I go to my table, and listen, I'm going to put 1 here, and it tells me it's 7. You could put 1 in yourself and figure out it's 7, right? The calculator is just a quick way to get an answer. So if S1 is 7, what is T1? 7. Even saying the phrase, the sum of the first term, is weird. But it simply means that the first term must be 7, because when you add up the first term, you get 7. Let's find S2. So put in 2. 18. What is the second term? $11. Because the first 2 terms have to add to give 18. If this is arithmetic, we've established that the common difference, thank you, we've established that the common difference is 4. Right? So if it is arithmetic, and it will be, the third term better be 15 because it's going up by 4 each time. Well, let's find S3. Let's find S3. S3 is 33. That means that these 3 numbers have to add up to 33. Well, we've already got 18. The number that you add to 18 to get 33 is 15. It was working. And you can stop at this point with the whole Sn thing and just go, oh, it's increasing by 4 each time, which means the 4th term is 19 and the 5th term is 23. And sometimes we have these exam questions, that's what we're talking about here. Sometimes we have these exam questions which are, brutal in their complexity, like this one. I mean, this was brutal. I don't care how you find a strategy. That's a good exam question, but it's mountainous in terms of the work. And then sometimes you have questions which are just as difficult, but have an elegant solution. That you can just look at it and go, wait a minute, if I find S1, that's the first term. If I find S2, that's T1 plus T2, and I can figure it out from there.